Everyone, today I'm going to discuss about valence bond theory, which is a main important topic of the chemical bonding. The valence bond theory explains the formation of chemical bond based on quantum mechanical model. Based on the wave function of the electron. How you say like this? Okay, let us. Yeah, so let me. Hi everyone. So today I'm going to discuss about valence bond theory, which is the most important concept in chemical bonding of class 11th chemistry. And before going to discuss about valence bond theory, let us discuss the demerits of Lewis electronic theory. So first, let us discuss Lewis electronic theory, which is a purely based on octet rule we say. So here now I'm going to talk about demerits of Lewis electronic theory. Lewis electronic theory, how the Lewis electronic theory failed to explain the chemical bond formation, how valence bond theory came into the existence, how the valence bond theory came up for the explanation of the structure of explanation of the structure of the molecules. So let me talk about Lewis electronic theory. Defects. Number one is Lewis electronic theory completely failed in the explanation of formation of chemical bond. Number two, it could not explain bond dissociation, enthalpy, and bond length. Lewis electronic theory absolutely failed to explain the bond dissociation enthalpy, bond length, while the formation of the chemical bond. So these are the failures of valence bond theory. Third point, not only Lewis electronic theory, but also Vesper theory. Vesper theory also could not explain the geometry of the complex molecules, only explain the simple molecules, that too theoretically. Theoretical explanation of the shapes of the molecule, geometry of the molecule. And the Vesper theory has limited applications, and it could not explain the polyatomic molecules also. That means here Lewis electronic theory and Vesper theory, so are the two theories could not only explain theoretically but not experimentally. Let us go for the detail this bond dissociation enthalpy, how it couldn't explain the bond dissociation enthalpy and bond length. If you take example of hydrogen molecule, hydrogen molecule, if you take 1 mole of hydrogen molecule and if you want to break this 1 mole of hydrogen molecule to gaseous atoms, if you want to change, the energy required is how much? 435 kilojoules per mole. As you know that hydrogen, between the two hydrogen atom, there is a single covalent bond is there. Single covalent bond means sharing of one single pair of electrons between the two hydrogen atoms. And breaking of this bond, energy required is 435 kilojoules per. The bond length is how much? Bond length is 74 picometers. The bond length is 74 picometers, and 1 mole of this single bonds breaking energy required 435 kilojoules per mole. Similarly, if you take another molecule, F2 molecule, if you take 1 mole of F2 molecule, fluorine molecules, in order to change into fluorine gas, gaseous atoms. So energy required is how much? 155 kilojoules per mole energy required. If you observe that between two fluorine atom, also there is single covalent bond is present, whose bond length is how much? 144 picometers bond length between the two fluorine atoms. Two fluorine atoms share single electron pair. The bond length is more here. The bond length is shorter here. And hydrogen required 435 kilojoules per mole, whereas the fluorine required 155 kilojoules per mole. Why there is a difference? Why there is a difference in terms of bond dissociation enthalpy, though both molecules have single covalent bond is present between the hydrogen, fluorine. Both are sharing single electron pair. Bond dissociation enthalpy, bond length. The Lewis electronic theory could not explain the reason for this different in bond dissociation enthalpy, bond length for single covalent bond between the hydrogen, fluorine. So this is the main drawback. So after that, the Vesper theory explained the theoretical explanation of the shapes of the molecule and the geometry of the simple molecules, and not experimentally, we say. In order to explain the bond dissociation enthalpy, bond length during the formation of chemical bond, in order to explain the geometry of the molecule perfectly and the formation of the chemical bond, a new theory has come up, that is VBT, valence bond theory. We say valence bond theory. This valence bond theories are two theories. One is what we call means the valence bond theories are one is valence bond theory based on hybridization, and other one is molecular orbital theory. One is molecular orbital theory. So VBT based on hybridization, molecular orbital theories, we say. These both theories completely based on, both are the theories completely based on the atomic idea of atomic orbitals, number one. Number two is modern electronic configuration of elements. Number three is so wave wave function of electron. This is purely based on quantum mechanical model. And the fourth point is so atomic orbitals, electronic configuration, wave function of electron, and overlappings of atomic orbitals. So overlapping of atomic orbitals, simply hybridization. Hybridization. That means here valence bond theory was introduced in order to explain the chemical bond, particularly covalent bond. This theory purely based on the knowledge of atomic orbitals, knowledge of what we say atomic orbitals, number one, the knowledge of electronic configuration, number two, wave function, quantum mechanical model. So, and overlapping of atomic orbitals, that means hybridization. So a variation and superposition or superimposition of the wave functions of electrons. This valence bond theory was proposed. So let us discuss how the bond formation takes place as per this valence bond theory. So by taking one simple example of so what it is. So already you know that the hydrogen plus hydrogen together means two hydrogen atoms combined to form hydrogen molecule. So how this hydrogen and a hydrogen atom combine together to form hydrogen molecule, let us discuss based on valence bond theory. Let us start. Now, so based on this valence bond theory, okay. Imagine two hydrogen atoms. So so here one hydrogen atom is present and another hydrogen atom also present. Two hydrogen atoms are present far away to each other. At the distance of r equal to how much? 300 picometers. Both hydrogen atoms are present at the distance of 300 picometers. The two hydrogen atoms are present at 300 picometers. So, and these two hydrogen atoms, between these two hydrogen atoms, there is no attraction force. There is no attraction force between the two hydrogen atoms. That means, so two hydrogen atoms are not bonded each other at this r equal to 300 picometers. When these two hydrogen atoms are brought at the distance r equal to 150 picometers, 150 picometers distance. So the two hydrogen atoms start attracting each other. When the R distance decreases to how much? 74 picometers between the two hydrogen atoms. More attractive force will develop between the two hydrogen atoms and forms, what is that? H2 molecule. As you know that molecules are stable than the respective hydrogen atom. That means here two hydrogen atoms, individual atoms have high energy than the respective molecule, we say. So the formation of this H2 molecule purely based on quantum mechanical model, quantum mechanical model we say. So what is the quantum mechanical model? So what it explained means if we go detail, so a single hydrogen atom consisting of nucleus at the center, one proton is present and around this one electron is present. Let us discuss this is a hydrogen atom and it consisting of electron Ea. Hydrogen atom Ha, one hydrogen atom which is given symbol Ea electron it possesses. This electron is moving around this nucleus. So this electron has the wave function. And in other case, there is a B hydrogen atom also having the same nucleus and electron is moving. And here is hydrogen atom B and its electron will be EB we call. Now this electron, so between this, so nucleus and electron, there is attraction force. Means the electron bonded with this nucleus and this electron is bonded to this nucleus. And before formation of the bond, both atoms are far away to each other. The distance between them is 300 picometers. Both atoms are not attracted. When these both atoms are brought very closer at the distance, so minimum distance, what happened? The electron of a hydrogen atom attracted to the nucleus of B hydrogen atom. Similarly, the electron of B hydrogen atom is attracted to the nucleus of A hydrogen atom. When both hydrogen atoms are brought very close between them, so attraction force will develop. That attraction force will make the atoms overlap. So both atoms overlap. So here the overlap, the distance between the means both atoms. So between them, due to the increasing of attraction forces, due to the decreasing of potential energy, so both atoms are brought close. How much the distance? R equal to 74 picometers distance. At this distance, the attraction force between the two atoms will be so more such that to form the bond. Such that to form the bond we say. So then here we have to discuss two aspects here. Two things we have to discuss. The individual atoms will have more energy than the respective molecule we say. That means when these individual atoms combine, their potential energy decreases. Their potential energy decreases. How the potential energy decreases? So now we'll discuss with the energy profile diagram of this energy profile diagram for this hydrogen molecule formation. So we'll discuss now. See, look at this diagram. Look at this graph. In this graph, There are two hydrogen atoms. Here is one hydrogen atom here. There is another hydrogen atom is present. So both are present far away to each other. The internuclear distance will be R will be, for example, 300 picometers. When both atoms are far away to each other, so distance is more, internuclear distance is more. Internuclear distance means if two hydrogen atoms, so have their respective nuclei. This is A hydrogen atom, this is a B hydrogen atom. The distance between the two nuclei, of both hydrogen atoms is said to be R. So when R increases, force of attraction decreases. When R decreases, the force of attraction increases. When force of attraction increases, bond formation taking place. Okay, now let us discuss. This is the energy profile diagram of H2 molecule. So energy taken on this y-axis, potential energy, PE energy is taken. And on this x-axis, internuclear distance is taken. Internuclear distance, R is taken. R is taken means, so R is taken on this x-axis, and potential energy of the molecule, potential energy of the hydrogen atoms taken on this y-axis, we say. Now, so when you bring the hydrogen atom closer to each other at the minimal distance of 74 picometers, 74 pico. Now see, the energy of these both hydrogen atom more than zero individual atoms having this energy is more. When both hydrogen atoms brought very close to each other, and the energy of the both hydrogen atom decreases as the R value decreases, radius internuclear distance decreases. At the 74 picometers bond length, at the 74 picometers of R, so what happened here? The N bond formation takes place completely. Then so bond energy, bond enthalpy, so change will be minus 435.8 kilojoules per mole. Energy is released. Energy released when hydrogen molecule is formed here. So when hydrogen molecule is formed, that bond, so energy is released, that is equal to minus 435.8 kilojoules. And when this extent of overlap between the two hydrogen atom increases, when the extent of overlap increases, so then the nuclei of A and nucleus of A atom, nucleus of B atom start producing repulsive force. Repulsive force will increases when both hydrogen atoms brought very closer to each other. So when repulsive force will operate, so what happened means, so the repulsive force dominate, then atoms again repel or atoms, so the bond will be not formed. So here is at the minimal distance at 74 picometers of the distance, where the repulsive forces between the nuclei and is equal to the attraction forces. When attraction forces so are equal with the repulsive forces, there is a formation of the chemical bond building. If the repulsive forces will dominate, no bond formation. And if the attraction forces, so the attraction forces dominate, also no bond formation we say. But when there is attraction forces are balanced with the repulsive forces, there is a formation of the bond. So both atoms will be in the equilibrium. Both atoms will be in the equilibrium state. Equilibrium state we. So let us go for the detailed discussion of another graph. Look at this graph, and in this graph, so what we understand, see, both hydrogen atoms are separated at the distance of r equal to 300 picometers. So, and the energy of both hydrogen atoms, so if, as per this graph, their potential energy is equal to zero when both hydrogen atoms are brought to the distance of r equal to 150 picometers, then the attraction force, the force of attraction increases between the both hydrogen atom. So both means these both hydrogen atoms brought very closer, and so the attraction force increases if you decrease the R value 74 picometers. At the 74 picometers, what happened? The attraction forces increases, then the potential energy of both hydrogen atom decreases. Potential energy of hydrogen atom decreases. As per this graph, you can see the potential energy when the R value reaches 74 picometers, then so the covalent bond is formed between the both hydrogen atoms. Both hydrogen atoms are overlapped here. Their atomic orbitals are overlapped. Then so hydrogen molecule is formed here, and during this minus 435. So 0.8 kilojoules per mole. So energy released when this hydrogen molecule is formed. So the bond dissociation enthalpy change will be 435.8 kilojoules per mole when H2 molecule. So as the R value decreases to 45 picometers, then between the both hydrogen atoms, there is a repulsive force. Repulsive force start increasing, dominate over the attraction forces, then atoms means no more bond will be formed. So here what I'm going to tell means when the repulsive forces are equal to the attraction forces, and between the both atoms, so equilibrium will be maintained, then there will be so chemical bond formation takes place. Chemical bond formation takes place. So this is the graph versus potential energy of the hydrogen atoms versus so internuclear so axis or bond length. So we say similarly. So this is the graph that we get for the hydrogen atom, and if you observe for the nitrogen, and if you observe for the oxygen, so the for nitrogen, so here for the formation of nitrogen molecule, see energy, potential energy decreasing. So bond formation takes place at around so 930. So bond formation takes place. So energy enthalpy change will be around so 930. This N2 molecule formation takes place. So when the R value decreases, similarly for the oxygen, you can check the bond enthalpy change will be, so it will be around so 500. So 530 around. So that oxygen molecule formation takes place. Bond enthalpy change takes place when R value decreases, then attraction force between the atoms also increases. During this, enthalpy change also takes place, that is bond enthalpy change. So this is about based on this is about valence bond theory and formation of hydrogen molecule, formation of N2 molecule and oxygen molecule as the two hydrogen atoms and two nitrogen atoms come closer, the distance decreases between them, then attraction force increases. So in the next class will address about, or next class I'm going to discuss about so how this